All right, welcome to another exciting math video. That's what's happening right about now, is excitement and math and videos. So let's do this. So first up, all right, what we're doing right now is, if you're doing these things in order, we have completed all of the algebra that we need to do for exponents. So next up, what we're going to do is we're going to move into graphing. And at some point in the near future, what you're going to do is all the things you learned in Unit 1 with mapping notations and reflections and stretches and all those sorts of things, we're going to do that again with these new exponential functions. But in this section, okay, what we're going to do is we're just going to look at some of the basics right now. So first of all, an exponential function can be identified if you have an x as an exponent. Okay, so anytime you see x as the exponent, which has never happened up to this point, it's happened in the equations we were solving, but it hasn't happened in any graphs that we have done until today. So what we have here, if you look at all of the equations below, you have x as an exponent, and they are all a number to the power of x. And what that number is always a positive number. So you see here that b has to be greater than 0, the number that's to the power of x. And it also cannot equal 1. 1 to the power of anything is 1, so we don't really do that. It actually turns out to be a linear function. But what we have here, okay, is we have some examples of equations where you have a number to the power of x. These are exponential functions. And then a little later in the next section, you're going to see like the one below where you have still x as an exponent. It's an exponential function, but there's all these extra numbers and negatives added in. And that's when we get into stretches and translations and reflections. So we'll do that another time. Okay, so what we're going to do right now is we're just going to take a look at what some of these graphs will look like on Desmos. So what I'm going to do right here is I just have one function right here. It's y is equal to 2 to the x. And then we're just going to compare what happens if I change that value of 2 into other numbers. They have to be greater than 0, and they have to be not equal to 1. So let's just go up and try 3 to the x, 4 to the x, and see what happens. In this particular equation, you have a y-intercept of positive 1, and we have no x-intercept. Looks like there may be an x-intercept, but as we go through these points here, you can just see that the y value just getting closer and closer to 0. So it's not actually intercepting the x-axis. It's just getting closer and closer to it. And you can also see that if you read this graph from left to right, like an English sentence, you can see right here that as you move from left to right, the graph is increasing. It's going up. So let's see what happens if I do some other functions like y is equal to 3 to the x. It's more or less the same thing. It's just a little bit steeper. Has the exact same x-intercept. It has a similar shape. And you can see also as you move from left to right, it's increasing. What happens if I change that to a 4 to the x? I'm going to get something like this right here. It's basically the same. And then as I increase that number, say if I go to 44, it just gets more square shaped, but it has the same y-intercept and so on. So you can see that these graphs are very similar to one another. Okay, and then what happens if I choose a number that is less than 2, can't be 1, can't be less than 0, so we're only going to go with numbers between 0 and 1, and here's where you're going to see something different happen. Okay, if I put in 0.5 to the x, all of a sudden, my y-intercept is the same, but you can see right here that it looks like a reflection on the y-axis. It's actually not considered to be a reflection, but you can see that the graph, as you move from left to right, is decreasing instead of increasing, and that will happen for any value that is between 0 and 1. So if I change that to 0.2, it's more or less the same thing. I can change that to 0.02 or 0.0002, and you can see more of these things type of things try to happen, all right? If I put in a 0.9, you're going to get sort of the same thing, but you can see right here that it takes a little longer to get there, but you can see also there's a y-intercept and so on. So that's just giving you a little look at what the different graphs would look like. So you can say that basically anytime, let's just get rid of this because we're not doing this right now, but we can say that anytime that b is greater than 1, and b is the number that's to the power of x, anytime you have that happen, you have a growth curve. From left to right, it's increasing with a y-intercept of 1. And anytime that your b value is between 0 and 1, like it is above, you have a half, which is 0.5 or 0.1. You can see that they are decreasing as you move from left to right, with still a y-intercept of 1.